Yeah. Good evening, children. Good evening, online students.
Good evening.
Yeah. Hi, Hari Pranav, Swati, Niveda, Laksha, Srivatsan, and Sabarna Sadhana. Good evening. All right. So this is exercise 13.8 from NCERT. From NCERT. All right. Okay. So what is the formula to find the volume of a sphere? 4/3 pi r cubed. 4/3 pi r cubed. Volume of a hemisphere? 2/3 pi r cubed. Correct. 4/3 pi r cubed and 2/3 pi r cubed. Okay. Now see this question. Find the volume of a sphere whose radius is given to you. So you just have to substitute the value 4/3 pi r cubed, and r will take the value 7 and 0.63, and that's it. This is find the amount of water displaced by a solid spherical ball of diameter 28 centimeters, 0.21 meters. So again, it's about volume, the amount of water displaced. So like, how do we understand this question? Supposing there is a beaker full of water. There's a beaker full of water, and you gently drop a spherical ball of radius 28 centimeters into this beaker. This beaker is full of water. You gently, because if you throw it, then the water will splash. You're not throwing, you're gently lowering a solid spherical ball of diameter 28 centimeters into this beaker, which is full of water. So what will happen? The water will overflow. Why? Because the sphere displaces. The sphere takes, occupies some space inside the beaker. So proportionate to that, some water will overflow. So the water that is displaced or the water that overflows, the water that is displaced, or the water here in this case, the water that overflows will be equal to the volume of the sphere. Whatever water is displaced, whatever water overflows, that volume of water will be equal to the volume of the sphere, because the beaker was full of water. The beaker was full of water. When you lower a sphere, the sphere needs some space inside the beaker. So there is some amount of water which will overflow. The amount of water that overflows will be equal to the volume of the sphere. All right. So find the amount of water displaced. So the amount of water displaced will be equal to the volume of the sphere. Just find the volume of the sphere, 4/3 pi r cubed. Whatever is the volume of the sphere, that is the volume of water displaced. All right. I'll share all this with you, so I'm not. You understand? You just have to substitute the value of r in the formula and calculate. All right. I'll share the images with you tomorrow. I just need to change the presentation. I made it long back. I want to change the presentation. I'll change the presentation. That's why I'm not asking you to take online students also. I'm not asking you to take screenshots because I want to change the presentation. Tomorrow I'll share the images with you. I'll change it and share the images with you. The diameter of a metallic ball is 4.2 centimeters. What is the mass of the ball if the density of the metal is 8.9 grams per centimeter cube? See, when we are not sure if it is volume or area, the unit itself will tell you 1 centimeter cube. 1 centimeter cube of the metal has a density of 8.9 grams. That's what is given there. This metallic ball is made of some material. 1 centimeter cube of that material has a density of 8.9 grams. The sphere is made of some material. Okay. 1 centimeter cube of the material which the sphere is made of has a density of 8.9 grams. So that means we should find the volume only. For 1 centimeter cube, the density is 8.9 grams. So you should find the volume of this spherical metallic ball. 4 by 3 pi r cube. Supposing you get 100, for example, 100 centimeter cube. For example, the volume of the sphere is 100 centimeter cube. So what will be the mass or the density? 1 centimeter cube, 8.9 grams. 100 centimeter cube, 100 into 8.9 grams. Correct? And if the answer you get, not in this example, if the answer you get is more than 1000 grams, you should convert it to kilograms. If the correct actual answer you get is more than 1000 grams, you need to convert that to kilograms. Online students, I have shared my screen. Visible to all of you?
Yes, ma'am.
Yes, ma'am.
Okay. All right. So we have to find the volume here because 1 centimeter cube has a density of 8.9 grams. So how many centimeter cube is in this spherical ball? How many centimeter cube is there? 4 by 3 pi r cube centimeter cube. So find the volume and hence find the mass. Correct? Okay. This is important. The diameter of the moon is approximately 1/4 of the diameter of the Earth. The diameter of the moon. Now, we know that the Earth is not a perfect sphere. Is the Earth a perfect sphere? Then what is the shape of the Earth? What's the shape of the Earth? Sorry? Oval. What is it called technically? Okay, it's the shape of the Earth is said to be an oblate spheroid. Oblate spheroid. Okay, so it's not a perfect sphere, but we're just assuming it so. Assuming it meaning we're just trying to find, assuming it's a sphere, we're trying to find the approximate value. The diameter of, so here both moon and Earth are spherical objects, all right? So the diameter of the moon is approximately 1/4 the diameter of the Earth. What fraction of the volume of the Earth is the volume of the moon? This one alone, we'll just practice it now in the class also. Class, also when I share the image tomorrow, you will do it once again in your book, all right? Just for the sake of practice. Okay, let me work this one for you. The diameter of the moon, so let me call it like this. Diameter of the moon is approximately, meaning now we can't say approximately. Approximately is also equal to only now. Approximately is also equal to. Diameter of the moon is approximately 1/4, meaning 1/4 of, meaning into diameter of the Earth. Diameter of the Earth. Whatever is there, we have just written it using symbols in an equation form, so it's easy to understand. So from this equation, we can read it easily. Diameter of the moon is equal to 1/4 of the diameter of the Earth. Correct? Okay. So now we'll do one thing. So what is diameter of the moon? We'll say, so the moon is smaller in size when compared to the Earth. It's smaller in size. Okay. So we'll use small r for moon. We'll use capital R for Earth. All right. So what is diameter? Twice radius. Correct? Diameter is twice radius. So let me write diameter of the moon as 2r is equal to 1/4 into 2r. What is the diameter of the Earth? Diameter of the Earth is also twice radius. So how do you differentiate? 2 capital R, or you can use R1, R2. I'm using small r for moon and capital R for Earth. All right, now let's work this. Let's work this and find the relationship between the radius of the Earth and the radius of the moon, because radius is what we want. Both are spheres. We want the radius. All right. So you can simplify however you want. So 2 ones are 2 twos are cross multiply. So we have 4r is equal to r, or r is equal to 4r. That means the radius of the earth is approximately 4 times the radius of the moon. That's what we understand from this equation. The radius of the earth is approximately 4 times the radius of the moon. Now let's answer. So now we've got the relation between the radius of the earth and the radius of the moon. And that's what we want because both are spheres. And to substitute in the formula, we need the value of r. We need the value of r. Now we will wonder, now we don't have the numerical value. We don't have the numerical value, but we have the relation at least. We have the relation. So you will see how it is helpful in calculating in finding the answer. Now the question is, you have to answer this question. What fraction of the volume of the earth is the volume of the moon? Now, which is the bigger thing here? Earth. Volume of the earth is the bigger thing. And the volume of the moon is a smaller thing. Like if I ask you, what fraction of the class are girls? What fraction of the class are girls? So if that particular class has 50 students, in which 28 are girls. Okay, so what fraction of the class are girls? Girls is like moon here, and class is like earth. Girls like moon, class like earth, because class is the full thing, so like earth here. And moon smaller than the earth, so girls will be, the number of girls will be less than the total strength of the class. Okay, so if you're asked to find the fraction of the class that are girls, what will you do? 28 girls out of 50 students. So 14 times 2. So 14 by 25 is the fraction. The fraction of girls is given by 14 by 25. Correct? You will write girls in the numerator and the total class, the total number of students in the class in the denominator. In the same way here, to find the fraction, you need to write the volume of the moon in the numerator and the volume of the earth in the denominator. You want a fraction. So you want to write something in the numerator and something in the denominator. What in the numerator? The smaller one in the numerator, the larger one in the denominator, because that's how a fraction is represented. Okay. And that's what is the meaning of what is given here. What fraction of the earth is the volume of the moon? That means it is volume of moon by volume of earth. What fraction of the class are girls? So you'll get right. Let me just write that above this. So similar to what fraction of the class are girls? So you'll find girls by total strength of the class. Similarly, volume of moon by volume of earth. Are you sleeping? You're tired? Go wash your face if you want. Okay, so now required fraction. Required fraction is equal to volume of moon divided by volume of earth. Required fraction is equal to volume of moon by volume of earth. What's the volume of the moon? 4 by 3 pi small r cube divided by 4 by 3 pi capital R cube. Correct? 4 by 3 gets cancelled, pi gets cancelled. So we have r cube by r cube, which can be written as r by r the whole cube. Correct? Now, what is capital R? It's 4 times small r. So can we substitute? Instead of capital R, we'll use 4 times small r. Okay, so sorry. Yeah. So what is r by r? R by 4r, correct? R by 4r. Let me just Write it like this. I'll just change the way I've presented it. I'll just write this again in the next slide, children. I'll write the same thing in the next slide. I'll write it like this. Volume of moon by volume of earth is equal to 4 by 3 pi r cube divided by 4 by 3 pi capital R cube. So cancels r by r cube by r cube, which is r by r the whole cubed, which is r by 4r the whole cubed. You can say using 1. Using 1. You can go there and mark that as 1. Which one? This one is 1. So using 1. So r and r will get cancelled. So you have 1 by 4 the whole cubed, which is nothing but 1 by 64. Which is nothing but 1 by 64. 1 by 4 the whole cube, which is 1 by 64. So now when you cross multiply, what do you get? When you cross multiply, what is the answer you have actually? Let me write it here. We have got volume of moon by volume of this is just for you to understand, is equal to 1 by 64, right? Is equal to 1 by 64. That means volume of moon when you cross multiply is equal to 1 by 64 times the volume of the earth. On cross multiplying, volume of moon is equal to 1 by 64 into volume of earth. That means whatever is the volume of the earth, divide by 64. If you find the volume of the earth and you divide that into 64 equal parts, one part is the volume of the moon. Because that's a relation we have got. Volume of the moon, when you cross multiply, that's what we understand. Volume of the moon is equal to 1 by 64 into volume of the earth on cross multiplying. So what do we mean? What do we understand from this? Volume of the earth, you find the volume of the earth and divide by 64 equal parts. So one part is the volume of the moon. But the question here is to find only the fraction. So the required fraction is 1 by 6. This is just for us to understand. This one is just for us to understand. So this is not a part of the answer. So this is the required fraction. The required fraction is 1 by 64. Yeah, I finished 1 by 60. Now you can work this itself. This is not wrong. I wanted to show that cross multiplying, so I worked it like that. Now you can take down this. So you can continue with this now. This is equal to what, children? R by R the whole cube, meaning 1 by 4R the whole cube, correct? Oh, R by 4R the whole cube. So R and R will get cancelled. That's equal to 1 by 4 the whole cube, which is 1 by 64. This is the required fraction. 1 by 64 is the required fraction. All right, take down this. Don't copy the question, just to practice. Yeah. Please practice this one, children. I'll give you 3 minutes time for this. This one is correct. Don't think I've striked it and it's wrong. This one is correct.
Miss.
Oh, yes, Haripranam.
Miss, how you got 2R, Miss?
2R. Where have I written 2R?
Miss, 2R is equal to 1 by 4 into 2 capital R, Miss.
Okay. Here. Okay. So what is the diameter, Haripranam? Twice radius, no?
Yes, Miss.
Okay. So I have taken the radius of the moon as small r and earth
Okay,
as capital R.
Okay, Miss.
Okay. So now
Okay.
diameter is twice the radius. So diameter for the moon, I've written 2 small r. Twice
Okay,
radius
Miss.
is diameter. And for the diameter of the earth, I've written 2 times capital R.
Okay, Miss.
Okay.
Fine.
Yeah, because diameter is twice the radius. Yeah, very good. Done, children? Yeah. Look at this question. How many liters of milk? Shall we do that answer again? Let's see how you can, how much you can recall and respond. Yeah. We are working the earlier one, so don't get confused with this. So what was given? Diameter of the moon. Diameter of the moon is approximately 1/4 of the diameter of the earth. Correct? So what is diameter? Twice radius. So diameter is twice radius. So twice radius. Here also diameter is twice radius, but we'll use small r and capital R. Small r for moon, capital R for earth. Okay. Now don't ask me why you've not written this M. Nothing, this M is nothing. This is just to say diameter of the moon symbolically. That M is just to say the diameter of the moon symbolically. And DE is just to say diameter of the earth symbolically. That's not a part of the formula or something. So is equal to 1/4 into. All right. So 2 ones are 2 twos are. So you have 2r is equal to 1/2 into r. Okay, why all this on cross multiplying? On cross multiplying, what do you get? 4r is equal to r, or r is equal to 4r. Now we need to find what's the required fraction? Volume of the moon by volume of earth. This is the required fraction. So when you write the formula 4/3 pi r cube by 4/3 pi r cube, 4/3 pi gets cancelled. And r cube by r cube, you can even substitute here. If you want, you can substitute. You can substitute like this also. R cube by, what is r? 4r. 4r, the whole cube. Like this also you can substitute. R is 4r, no? So like this. Then it is r cube divided by 64 r cubed, correct? So r cube gets cancelled 1/64. So the required fraction is 1/64. Okay. How many liters of milk can a hemispherical bowl of diameter 10.5 centimeters hold? All right. So now it's important to understand the relationship between meter cubed and liters. 1 meter cubed is equal to 1 kiloliter. 1 kiloliter meaning 1 meter cubed is equal to 1000 liters. 1 meter cubed is equal to 1000 liters. And 1 liter is equal to 1000 centimeter cubed. 1 liter is equal to 1000 centimeter cubed. You need to remember this relation. All right. 1 meter cubed meaning what? Just imagine anything cubical. Let's imagine a cubical tank, a cubical container. Okay. Whose edge is 1 meter. Cubical container with edge 1 meter. So what will be the volume of that container? 1 into 1 into 1. Because cubical, no? So it will be 1 into 1 into 1. Volume. 1 into 1 into 1. A cubed. 1. So 1 meter cubed it will be. So if you have a cubical container whose edge is 1 meter, its volume will be 1 meter cubed. Now, if you pour liquid into this, it can hold 1000 liters of liquid. Approximately. That's what is the meaning of 1 meter cube is equal to 1 kiloliter. 1 kilo is 1000, no? Kilo means 1000. So both are the same. They're not different. Both are the same. You can say 1 kiloliter or 1000 liters. 1 kilo means 1000. So 1000, both are the same. Okay, so 1 meter cube is equal to 1000 liters. Meaning is 1 meter cube. When will you have a volume of 1 meter cube? So when we consider a cubical container of edge 1 meter, its volume will be 1 meter because 1 into 1 into 1 is 1. 1 meter cube will be the volume of that cubical container. If you pour liquid into this cubical container, it can hold up to 1000 liters of liquid. All right. That's the meaning of this relationship. 1 meter cube is equal to 1000 liters. 1 liter is equal to 100 centimeter cube. Sorry, 1000 centimeter cube. That means if you have a cube, I'm saying, see, the vessel can be any vessel. It need not be only a cubical vessel. I'm using a cube to find the volume easily. It can be any vessel whose volume is 1 meter cubed. Any shape, any vessel can be conical, cylindrical, whatever vessel it is, any vessel. Any vessel whose volume is 1 meter cubed can hold 1000 liters of liquid. Now the next one, 1 liter is equal to 1000 centimeter cube. So a cube whose edge is 10 centimeters. A cube whose edge is 10 centimeters will have a volume of 1000 centimeter cube. 10 into 10 into 10, 1000 centimeter cube. Now this vessel, this cubical vessel, which has an edge of 10 centimeter, will have a volume of 1000 centimeter cube. That means this will hold 1 liter of liquid. 1 liter. So any vessel it can be. It need not be a cubical vessel. I'm using cube so that I can explain easily. I can tell you like a cubical container, edge is 10 centimeters, so volume is 1000. So yeah, it's easy for me to explain with a cube. But the container can be any container. This is the meaning. So if there's a cubical container of edge 10 centimeters, its volume is 10 into 10 into 10,000 centimeter cubed. Now this container can hold 1 liter of liquid. That's the meaning of 1 meter cubed is 1000 liters and 1 liter is 1000 centimeter cubed. Remember this relation. So 1 meter cubed is equal to 1 kiloliter or 1 meter cubed is equal to 1000 liters. 1 kilo means 1000. This is one relationship. The other one is 1 liter is equal to 1000 centimeter cube. Write this each 3 times in your book. Online students, use the emoji, raise your hand. Okay, finish writing this. Finish writing this. Write each 3 times in your book. Yeah, online students, use the emoji, raise your hand. Hari Pranam, Srivatsan, Laksha, Swati, Niveda, Sadhana, and Sabani. Okay. Why Aniruddhan has not Aniruddhan? Who's that? Srivatsan has taken online class today.
Ma'am, I went to my friend's city, ma'am, so I came only in 6:30. So I'm not able to come to the center.
Okay. All right. All right. Thank you, Shruti. This is understood? Got this? All right. Now let's answer this question. How many liters of milk? Liter is volume only, no? Liter volume is something which you pour inside the vessel. When anything to do with the inside of the vessel is volume. How many liters of milk? Straight away it's volume, it's not surface area. Okay, so how many liters of milk can a hemispherical bowl of diameter 10.5 centimeters hold? So formula 2/3 pi r cube. Radius 10.5 by 2. Don't find 10. You can see it all depends on how convenient you are with decimals. So the radius is 10.5 by 2. So you can shift the decimal point. So it will be what, 105 by 20. So 521 times 5 fours are so 21 by 4. If you want to divide and write it as 5.25, fine. All that is your convenience. But all of us are convenient with fractions. Nobody can say, no, I'm not comfortable with fractions. I'm very comfortable with decimals. No. No. Okay. So all of us are comfortable with fractions than decimals. Yeah. So 2/3 into 22/7 into r cubed. Diameter is 10.5. So radius is by 2. Shift the decimal point by multiplying the numerator and denominator by 10. So we get 105 by 20 and simplifying 521 times 5 fours are. So the radius is 21 by 4 into 21 by 4 into 21 by 4. So calculate this, you will get the volume in centimeter cubed, correct? You will get the volume in centimeter cubed. Now, mostly we have a doubt with should I multiply or divide? So use this method. Use this method. Listen to this. Write the formula like this. What's the formula? This is centimeter cube. No, this one is centimeter cube. So what is the relationship between centimeter cubed and liter here? Oh, I cleared that, is it? Okay. What is the relation between centimeter cubed and liter? 1 liter is equal to 1000 centimeter cubed. 1 liter is equal to 1000 centimeter cube. Please write it like this. 1 liter by 1000 centimeter cube is equal to whatever answer you get here. Whatever answer you get here. So will be equal to x liters by this centimeter cube, whatever you get there. Now cross multiply, you will get the answer. I'll just see the sneak peek the answer and tell you. 303.1875. Okay, 303.1875. 303.1875 centimeter cube. One liter by 1000 centimeter cube is equal to x liters by 303.1875 centimeter cube. Now you'll ask me like, what is this? Why are you writing 1 liter by? I'll tell you why. It's using a ratio and proportion. 1 liter is to 1000 centimeter cube is as to x liters is to 303.1875 centimeter cube. This is the general relation. This is our specific situation. This is the general relation. 1 liter is 1000 centimeter cube. This is our question. So here I've written liter first and then centimeter cube. Here also I should write liter first and then centimeter cube. Or if I write 1000 centimeter cube is to 1 liter, then I should write is as to 303.1875 centimeter cube is to x liters. X liters because we have to find how many liters. So x liters or y liters. Is that fine? Now, what do you mean by is to? It's division. Now, if I say 5:3, what is that? 5/3. What is 5:3? 5/3. Okay, so I'll just go with the first one. Both are correct. Both are correct. Any order you can write, but you should maintain the same order on both the sides. If you write liter centimeter cubed, on that other side also it should be liter centimeter cubed. So now is2 is converted to division. So now let go the units. Let go all the units. So 1 by 1000 is equal to x by 303.1875. That's what I wrote earlier. 1 liter by 1000. You can write this. Please write this. The teacher will be more happy with you. Write this and then write this. Now cross multiply. So what do you get? 1000 into x is equal to 303.1875. So x is equal to 303.1875 divided by 1000. So that will be equal to 0.3031875 centimeter cubed. Oh, sorry, liters. Sorry, sir. You're converting it to liters, no? So many liters. So you have to find the volume in centimeter cube, and I'm telling you, if the radius or diameter is a decimal, convert it to a fraction and use the fraction for calculation. And then when you find the final value, it is 303.1875. Okay, 1875, correct? Now we have to convert that to liters. So write the rule. 1 liter is to 1000 centimeter cube is as to x liters is to 303.1875 centimeter cube. If you write liter centimeter cube, here also liter centimeter cube. Got it? And then S2 means division. And then cross multiply. Get the answer. This is the next question. A hemispherical tank is made up of, children, I'm not allowing you to write because it's all calculation. Even if you write, you'll only copy the numbers from the board. If I share the images, you can do the calculation at home and practice it better. Now you're just going to, meaning it's just number work. I'm making you understand the situation, how to go about the answer. And so your homework will be to do this at home, not just copying the answers, but to do the calculations yourself. And again, not with the calculator. Yeah. A hemispherical tank is made up of iron sheet, 1 centimeter thick. Okay. It's a hemispherical tank and the wall is thick. It's made up of iron sheet, 1 centimeter thick. The material is thick. So when the material is thick and you build anything using the thick material, the wall of that object will be thick. So a hemispherical tank is made up of iron sheet 1 centimeter thick. If the inner radius is 1 meter, then find the volume of the iron used to make the tank. So here there'll be 2 radius, one inner radius and one outer radius. The inner radius is 1 meter or 100 centimeter. Okay, so what is the inner radius? The inner radius will be 1 meter, not will be, sorry. The inner radius is given to be 1 meter, which is 100 centimeters. What is the thickness? 1 centimeter. So what's the outer radius? 100 plus 1, 101 centimeter. Sorry. All right. Now don't add inner radius is 1 meter. Thickness is 1 centimeter. Don't add 1 meter and 1 centimeter and say 2 something. You know, you will not do that. I'm just telling you. Be careful with the units. Inner radius is 1 meter, which is 100 centimeter. Thickness is 1 centimeter. So the external radius will be 101. Internal radius plus the thickness. Now what's the formula? Somebody online tell me what is the formula to find the volume of a hemispherical tank?
2 by 3 pi r cube.
That is if the wall is thin. When there are two radii, what will be the formula?
Miss 2 by 3 pi into r cube minus r cube, miss.
Correct. 2 by 3 pi. It's actually 2 by 3 pi r cube, right? When there are two radii, it will be 2 by 3 pi in bracket capital R cube minus small r cube. The 2 by 3 pi r cube will become r cube minus r cube. Two by 3 pi r cube. This is the formula. If there's only one radius, if the wall is thick, it will be 2 by 3 pi r cube minus r cube. Substitute, put the values in this formula. So it will be 2 by 3 into 22 by 7 into r cubed, 101 cubed minus r cubed, 100 cubed. Correct? Yeah. Now you have to calculate this 101 into 101 into 101. Subtracting. If the wall is thin, that is if there's only one radius, it will be 2 by 3 pi small r cubed. 2 radius, 2 by 3 pi in bracket capital R cubed minus small r cubed. All right. So the question is find the volume of iron used to make the tank. So whatever answer you get, so many centimeter cube. Centimeter cube. How do you convert an answer in centimeter cube to meter cubed? So supposing you get like 5, 6, 7, 1, 2, 3, 4, 5, 6 centimeter cube. Supposing this is the answer. How do you convert centimeter cube to meter cube? See, all this you should be very sure and very comfortable with. How do you convert centimeter to meter? How do you convert centimeter to meter? Divide by 1000. 100. Divide by 100. To convert centimeter to meter, we divide by 100. So to convert centimeter cube to meter cube, you should do the same thing 3 times. So 5, 6, 7, 1, 2, 1, 2, 1, 2 divided by. See, to convert centimeter to meter, what do? You should divide by 1000. Divide by 1000. Oh, sorry. Divide by 100. 100. Okay. So divide by 100. So Anirudh is so, not Anirudh, what's your name? Abhishek is so influencing. That, that mesmerizing people, what is it called? You say something and I just receive it. So 100. Okay. So to convert centimeter to meter, we divide by 100. To convert centimeter cube to meter cube, do that thing 3 times. So you divide by 100 once, no, do it 3 times because centimeter cube to meter cube. All right. So 2, 4, 6 zeros. 2, 4, 6 zeros. So it will be 567 meter cube. 567 meter cube. So all this you should be very confident because it's not new. Conversion is not new to you. You know how to convert any unit to any unit. Whatever you do there, same thing you should do. But if it is square units, you should do it 2 times. If it is cubic units, you will do it 3 times. The same thing, whether you're multiplying or dividing, whatever you do to convert one unit to another unit, same thing you should do here. Just that if you're converting from one square unit to another square unit, do it 2 times. If you're converting it from one cubic unit to another cubic unit, do it 3 times. If you're multiplying 3 times, dividing 3 times. So Tuesday's class, You have to come prepared with the volumes and surface areas. This chapter fully. Learn the formula. That's very important. All right. So on that, so on Tuesday, we'll take a revision on this chapter, this full chapter. So please come prepared with the formula. Only then the class will be interesting for you. Yeah. So find the volume of a sphere whose surface area is 154 centimeters square. So what is given here? Surface area is given. Surface area is equal to 154. What's the formula to find the surface area? 4 pi r square is equal to 154. So work this and find the value of r, and then find the volume. Whenever you're given something like this, surface area is equal to 154 is given to you. That means 4 pi r square is equal to 154. So work this and find the value of r. Everything is, see, 4 into pi is 22 by 7 into r square is equal to 154. So you can find the value of r. And once you find the value of r, you can find the volume of the sphere. So here, a dome of a building is in the form of a hemisphere. Okay. From inside, it is whitewashed at the cost of whatever you see there. If the cost of whitewashing is 20 rupees per square meter, find the inside surface of the dome, volume of the air inside the dome. So how do you find the cost of whitewashing? How do you find the cost of whitewashing? The dome is whitewashed, right? The dome is hemispherical. It's given there. The dome is hemispherical. And if it's a dome, you will only, whitewash the curved surface area. Because the circular portion will be open. The circular portion of the dome will not be closed, no? Otherwise, you cannot see the dome. Just imagine that the ceiling had a dome. Then the circle will be open. If that circle is also plastered, then you cannot see the dome, right? Just imagine, this is the ceiling, and supposing there's a dome like this, and if this one is covered, if the circular portion is also covered, if it's like flat, it's covered like this, then how will you see the dome? So whenever it's a dome, from inside, if you see, you'll only see the CSA. The circular portion will be open. That will not be covered with, that will not be closed. Or if you're whitewashing from outside also, you can only whitewash the CSA. But it's given from inside only here. It's given from inside. So from inside, when you're whitewashing, the circular portion is open because it's a dome, and there's no point in having a dome in the ceiling if you're covering the base. So you'll only be whitewashing the CSA. So how will you find the cost of whitewashing? CSA into rate will be the total cost. Correct? Will be the total cost. CSA into the, see, you will find the CSA of your dome, the curved surface area. Why curved surface area? Because you're whitewashing, so we'll have to find surface area. You're going to touch the surface of the dome, the curved surface area. You're not stuffing something inside the dome. You're working on the surface of the dome, the curved surface area of the dome. So find the CSA and multiply that with the rate, that is rupees 20. You will get the total cost, correct? So CSA into rate is equal to total cost. See, sometimes volume into rate also can be total cost. Don't think this is a formula. It depends on the situation. Sometimes volume into rate also will be total cost. So in this situation, CSA into rate is the total cost. So in this situation, how do you find the CSA? CSA is equal to total cost by rate. Total cost by rate. Yes or no? Because CSA into rate is equal to total cost, the CSA will be total cost by rate. Yes or no? So you have the total cost there and the rate. If you divide, you'll get the CSA. And that is only that's only the inside surface area of the dome. That's only the inside surface area of the dome. Then you should find the volume of the air inside the dome. Volume of the air inside the dome. For that, you need the radius because you have to find 2 by 3 pi r cube. To find the volume of air inside the dome, you need the radius. 2 by 3 pi r cube. Radius is not given, but you know the CSA, no? Using the CSA, you can find the radius because what is CSA? 2 pi r square. You found the CSA. In the earlier working, you found the CSA. So 2 pi r square is equal to whatever answer you got. When you work this, you'll find R. And when you find R, you can find the volume of the air in the tube. Do this now. This is a test. All of you do this. You can take down the question if you want. As I told you, I'll be sharing all the images on WhatsApp tomorrow. Yeah, please work this one. So somebody online tell me what is the CSA of the dome?
Oh my god, it is 249.48.
1 second. Yeah, repeat, Swati. 24.
9.48.
Yeah, correct. 249.48 meters square. Very good. So that is the curved surface area. 249.48 centimeter square is the is the CSA, inside surface area. So CSA of the dome. Next, volume. So you should work that to find the radius. You found the radius also, Swati?
Ma'am,
Can I say,
Yeah? Yeah, yeah. Go ahead.
6.3 meter?
Niveda, 6.3. Okay. Yeah, 6.3, correct. So 249.48. I'll show you the working here. So see here, children. Look at the working here. Inside surface area is 249.48. That is the CSA. That means 2 pi r square is equal to 249.48, correct? 2 into 22 by 7 into r square is equal to 249.48. So r square will be equal to, the 7 will go up to the numerator. 2 and 22 denominator. When you simplify, you cancel, you get 39.69. See, if you want to, okay, let me cancel it for you, children. 11 2s are 22. 11 2s are 22. 2 is the remainder. 11 2s are 22. How much is the remainder? 7 is the remainder. 7. So 6 are 66. 8 is the remainder. 8 are 80. 22.68 you get. Okay, then again you can cancel. 2 1s are 2. 11.34. Again, 2 1s are and 2 will be 5.67. Okay, so I got r square is equal to, on cancelling out, r square is equal to 5.67 into 7. So now I multiply. See, now at this stage, you can also do this. R square is equal to 567 by 100 into 7. Is that fine? Okay, so now you can multiply and find the square root. I'll tell you different ways of doing this. 567 into 7. I get 3969. I cancelled. I got 5.67 into 7. R square is equal to 5.67 into 7, which you can multiply and you will get 39.69. That's also fine. Now find the square root. You should know the division method to find the square root. You can also write r square is equal to 3969 by 100. So how do you find the square root? 3969. You'll have to pair it like this. 6 6 are 36. 3 is the remainder. The next pair comes down. Double the quotient. So 12. Whatever you place, you must place the same thing here. So 3, 3, 369 and 0. So 63 is the square root. 8 standard. 8 standard. Yeah, the special division method to find the square root of any number, perfect or imperfect square. So using that method, we find the square root, which is 6.3. No, I'm trying to say that there's nothing difficult about cancelling. If you didn't want the decimal point, no, here itself you can write this one as 249.48 by 100. That's all. If you don't want the decimal point, just write as this one by 100. So you'll get r square as something. R is equal to square root of that number. So if you have r square is equal to 3969 by 100. So r will be equal to square root of 3969 by 100. So r is equal to the square root of the numerator is 63. Denominator is 10. So you'll get 6.3. Now for Count the radius. How did you find the radius? Because CSA we knew. 2 pi r square is equal to 249.48. When you work that, you find the value of r. And use this value of r to find the volume of air inside the dome. So 2 by 3, this is hemispherical, 2 by 3 pi r cubed. All right. It's cold. This again is an important question. After that Earth Moon sum, diameter of the moon is approximately 1/4 the diameter of the Earth. After that, this also is a very important question. 27 solid iron spheres, each of radius r and surface area s, are melted to form a sphere with surface area s dash. Find the radius r dash of the new sphere and also find the ratio of s to s dash. So nothing, we can't remember any information. Okay, so just start working. That's what it is. Reading and thinking will not help. Don't read and think too much. Start working something. So what do we work? Here, 27 solid iron spheres. 27 spheres are melted and made into one sphere, right? So volume of 27 small spheres. Yeah. So volume of the 27 small spheres, or you can write it the other way around also. Volume of the sphere, the big sphere. The volume of the big sphere is equal to volume of 27 small spheres. That's what is given there. Volume of the big sphere is equal to volume of the 27 small spheres. All right? Okay. So how do you find the volume of the big sphere? 4 by 3 pi capital R cube is equal to the volume of the 27 spheres will be 27 into 4 by 3 pi R cube. Correct? So on either side, 4 by 3 pi gets cancelled. So we get R cubed is equal to 27 R cubed. Okay, they are saying radius is R dash. Okay, I didn't notice that. Sorry. Meaning, I just forgot about that. So I should write R dash here. R dash, so I should put the cube in a bracket. Because otherwise, if I put R dash cube like this, it will look like 13 maybe. So because it is R dash, I'm just using a cube like this. No, it's given that the radius of the new sphere is R dash. It's given. The radius of the small spheres is R. The new sphere is R dash. Is given. So 4 by 3 pi R dash cube is equal to 27 into 4 by 3 pi R cube. 4 by 3 pi gets cancelled and you have R dash cube is equal to 27 R cube. So what is R dash? R dash will be equal to the cube root of 27 R cubed. Because if it is like A cubed is equal to 125, A is equal to the cube root of 125. So R dash is equal to the cube root of 27 R cubed. So R dash is equal to, what is it? 3R. Cube root of 27 is 3. And R cube, cube root of R cube is R, 3R. So this is the relation. The radius of the new sphere is equal to 3 times the radius of the small spheres. Now we find the radius R dash of the new sphere. We found R dash is equal to 3R. You can't find a number. You can't find R dash is 15 centimeters, 20 centimeters. That we cannot find. Find R dash means this one. R dash is equal to 3R. You understand? R dash is equal to 3R. This is what you can find. Next, you must find the ratio S to S dash. What is S? The surface area of the original small 27 spheres. Each sphere. And what is S dash? Surface area of the new sphere. So you should find the ratio S to S dash is equal to correct? S to S dash is 4 pi R square by 4 pi R dash square. So gets cancelled, correct? So R square by what is R dash? 3R. So it will be, don't write 3R square like this. 3R whole square. So now this will be R square by 9R square. R square cancels, so 1 by 9. So the required ratio is 1 by 9. So once, if you work it mindfully, you know, you don't have to revise it at all. Everything is in the question. Everything is in the question. You just have to remember the formulae. Whatever is in English in the question, we are just converting it to a mathematical equation using the formula. That's all. Then once you write that first step, calculation only. We didn't do anything else. No big idea here. You will get R dash is 3R. And next question is S by S dash. Formula you should know 4 pi R square by 4 pi R dash square. Substitute and you get it. So when you're practicing this at home, do it very mindfully. Read the question. With full interest, you should work. Then you don't have to revise this at all. That is what is important. Ellame time being ஞாபகம் இருக்கிற மாதிரி படிச்சுனா அப்போ ஒரு வாட்டி எக்ஸாம்க்கு ரிவைஸ் பண்ணிட்டே இருக்கணும். Certain things you should remember like once for all. இனிமே இது படிக்கவே வேண்டாம். All that you can do with certain chapters like statistics, probability, certain sums and volumes and surface areas. Not everything. Then students might feel like, yo, namak dhaan kashtamā irukum. No. Many things need practice. Everything you cannot remember just like that. Certain, parts of mathematics, certain chapters here and in volumes and surface area, few sums like this, you don't have to revise again. Once you pandichave nalla gavanama pannina, you can remember. I don't mean to say that, mathematics, once you work, then you can remember. No, it's not like that. Many parts of the subject, you have to practice repeatedly. Practice only you can remember. Otherwise, you cannot remember. You will understand, but you will not remember. So 1 by 9 is a required ratio, correct? So see, a capsule of medicine is in the shape of a sphere of diameter 3.5 millimeters. So diameter is 3.5 millimeter. Radius will be 3.5 by 2. That means 35 by 20. 3.5 by 2 means 35 by 20. That means 7 by 4. You can have a fraction for radius. How much? இப்போ நான் fraction சொல்றேன். நான் maybe calculation decimal போட்டிருப்பேன். So you work whatever is convenient for you, you do. That's all. So don't get confused. She said fraction in the class and she's worked with decimal. You work however you want. I'm saying like you can take decimal value, you can take fraction, whatever is convenient for you. So how much medicine is needed to fill this capsule? You understand capsules, right? It's not a tablet. Not tablet. Capsule. So what is generally how does capsules filled with liquid are like something like, no, I'm very bad at that. Maybe like this, something like a pillow. Capsules which are filled with liquid. Okay. If you've seen, they are kind of a pillow kind of thing. Otherwise, capsules which are filled with the powder or some granules, it's like this. How is it? Now, this one is in the shape of a sphere. This capsule is in the shape of a sphere, like this. Otherwise, how do you see capsules? Do you see capsules like this? With hemispherical ends? Do you see capsule, cylindrical capsule with hemispherical ends? cylindrical. The capsule is cylindrical with hemispherical ends. Normally capsules look like that. This capsule is spherical, is a sphere. And if it's a capsule, there's medicine filled into it. So how much medicine is needed to fill the capsule? Fill, you're putting inside. Volume. 4 by 3 pi r cube. That's all. Just 4 by 3 pi r cube will give you the answer. Correct? Yeah, what is this one? What is this? When will you use this root of L square plus B square plus H square?
When we want to find the diagonal of a cuboid.
Correct. Diagonal of a cuboid. Diagonal of a cuboid. When will you use this one?
Radius of a cone.
Radius of a cone. Radius of a cone. Root of L square minus H square. R square. What is the relationship for a cone? Cone, it is L square is equal to H square plus R square. L square is equal to H square plus R square. So L square minus H square is equal to R square. So R is equal to square root of L square minus H square. Okay, what is this? What is this one?
Yes, volume of a cone.
Volume of a cone. This one? Correct. Volume of a hemisphere. Yeah, with two radius, meaning where the wall is thick. Volume of a hemisphere, which has internal radius and external radius. That is when the material is thick. A hemispherical bowl where the wall is thick. What is this one?
Volume of a hollow cylinder.
Here, no.
When there is a need to find the area between two circles.
Correct. Area between two circles. Very good. Area between two circles. Like this. This area of a ring. Area of a ring. This area is given by pi r square minus r square. Yes or no? Yeah, correct. Swati. Area of a ring. Ring. The area between two circles is given by pi capital R square minus pi small r square. Okay, then. Yeah, what is this?
Curved surface area of a hollow cylinder.
No. Sorry? நீங்க தான் நீங்க ஒரு நிமிஷம் அங்க ஸ்கொயர் யூனிட்ஸ் வேற போட்டிருக்கேன் அப்புறம் எப்படி நீங்க வால்யூம்ன்றீங்க புக் ரெஃபர் பண்ணீங்க Yeah, so Bhavishya bought it right here. No, please don't do that. 2 pi r into r plus h is the total surface area of a cylinder. You can just open the brackets and understand. 2 pi r into r plus h, right? So it is nothing but 2 pi r square plus 2 pi RH. If you open the bracket, 2 pi R square plus 2 pi RH. 2 pi R square plus 2 pi RH, correct? So what is 2 pi RH? It's the CSA of the cylinder. And what is 2 pi R square? Pi R square plus pi R square. This is the CSA of the cylinder. And this is the area of two circles. Pi R square is the area of one circle. 2 pi R square is the area of two circles. So this is the formula to find the CSA and the area of the two circles, which is the total surface area of a cylinder. 2 pi R into R plus H is the formula to find the total surface area of a cylinder. This one?
Curved surface area of a cuboid.
Yeah, correct. CSA of a cuboid. Okay. 2H into 2H into L plus B. What is 2 into L plus B? Perimeter of a rectangle. Perimeter of a rectangle. What's the perimeter of the cross section into height? CSA. I've told you, volume is area of the cross section into height. Curves of no, the way you did it, no, you referred and say, yeah, correct. I'm just thinking of that and still laughing. Area into height is volume. CSA into height is perimeter. Perimeter into height is CSA. Volume in, oh my God, so sorry. Area into height is volume. C is, oh my God. Perimeter into height is, I'm sorry. Perimeter into height is equal to CSA. So 2H into L plus B. 2 into L plus B is the perimeter of a rectangle. Perimeter into height. Perimeter into height is CSA. CSA of what? Cuboid. Because it's the perimeter of a rectangle. So cross section is a rectangle, then it should be a cuboid. Okay, I think I shouldn't spend so much energy. It's your time to remember all this. What is 12A? A.
Total length of the edge in a cuboid or cube.
Total length of the edge?
The edge in cube, ma'am.
Cube, very good. The length of all the edges of a cube. The length of, because a cube has 12 edges, right? A cube has 12 edges. A cuboid also has 12 edges. Each edge has a length of A units. So 12 edges, 12A. A plus A plus A plus A, 12A. So supposing you have a cube, you have a gift, and you packed it in a cuboid. If you have a gift and you have packed it in a cubical box, and if you want to use sellotape and fasten the edges of this cubical box, what is the length of the sellotape you will need? 12A. If you want to use sellotape and fasten the edges, so normally when we send a courier, like we are so, we pack it, we use sellotape all over. So like that, if you have a big cubical box, and if you want to fasten all the edges, you want to tightly seal the edges with sellotape. What is the length of the sellotape you will need? 12A, because 12 edges. So 12 into A, the length of each edge. Okay, I've sent this image on WhatsApp, children. You can Use this and learn. Okay, this one, just tell me this one. What is this?
And if it is a hollow cylinder and if you are willing to find the area of all the surface including the ring,
Correct.
we add the outer and inner and then the width area.
Very good, very good. Yes. This 2 pi r, very good, Swati. You answered most of it, almost all actually. This 2 pi RH, this 2 pi, this one is the, see, 2 pi RH means cylinder. 2 pi RH is cylinder. Again, see, I've told you, perimeter into height. Perimeter into height. Perimeter into height is CSA. For any solid that has a uniform cross section, perimeter into height is CSA, area into height is volume. This is not new. I have already told you this. Area into height, volume. Perimeter, for plane figures, what do you find? For plane figures, area and perimeter. When we were in 6th or 5th or 6th standard, square, rectangle, what we used to find? Area, perimeter, that's all. For the same area, perimeter, if you give some height, area, if you give height, area into height is volume. For that perimeter, height, CSA. Perimeter into height is CSA. What's the perimeter of a circle? What is the perimeter of a circle? Perimeter meaning circumference of a circle. 2 pi r. Circumference of a circle. Pi r square is the formula to find the area. 2 pi r into h. Which one has the cross section of which solid is a circle? Cylinder. The cross section of which solid is a circle? Cylinder. So 2 pi r is the perimeter of the circle into height is CSA of the cylinder. So when you see 2 pi RH, 2 pi r is the perimeter of the cross section into height. Perimeter of the cross section height is CSA. CSA of what? 2 pi r means circle. Circle means cylinder. So 2 pi small r h is the inner CSA. 2 pi capital R h is the outer CSA. And pi r square minus r square is the area of one ring. Into 2 will be the area of two rings. Because how does a hollow cylinder look like? Like I think I showed you that sellotape, right? The sellotape roll. So inner CSA, 2 pi RH. Outer CSA, 2 pi capital RH. Then on the top and the bottom of the sellotape roll, you find a flat thing, no? On the top. There's a flat thing on the top and bottom. They are the rings. Area of one ring is pi r square minus r square. Another ring, pi r square minus r square. So that's what is 2 pi r square minus r square. Okay, I've sent this image on WhatsApp, children. So you can memorize the formula and then check if you're able to spontaneously say what it is. You should be able to say spontaneously. That means you've memorized it correctly. Otherwise, no. So this is how, alphabets, language alphabets are taught to children. Or rather, I used to do that when I used to teach little children, alphabets. So, once again. So supposing you were to, teach, you have a very young, very little cousin who's just started school, okay, and you're helping him or her out to learn the English alphabets. So once he or she knows to write, identification is important. Writing, like drawing, children will write A, B, C, D. Somehow, like drawing, they'll start writing. But identification. So you should just write something like, and they should say immediately T, X, V, C, E, F, H. So when you write the letter, the child should be able to identify it spontaneously. That means the child knows it well, has learned the sound correctly. Or the child, so you can make out if you write S and maybe X, the child might get confused with the sounds. This is, it might say this is S and this is X. So it's easy to identify where the child has, confusion with. A, B, C, D, E, F, G, H வரிசையா சொல்லிடும். But நடுவுல கேட்டா சொல்ல தெரியணும்ல, அப்பதான் அந்த சவுண்ட் வச்சு அந்த வேர்ட் எழுத முடியும். So like that you can, that's what, with that idea only I prepared this. I think this includes everything. Let me know. If I've missed out on something, you can let me know. I mostly, I take utmost care in preparing anything. So I wouldn't have missed out anything. Just in case you find something, you can be a critic. I'll be happy. I'll correct it. Meaning I'll include that. Okay. So now we are going to talk about, the solid generated when a right triangle is revolved or rotated about its legs. Okay. When a right triangle is rotated about one of its legs. What is the solid generated?
Right circular cone.
A right circular cone. Okay. So this is the right triangle. Okay, so this is a right triangle. This is a right triangle. This one is the hypotenuse. This is one leg. This is the other leg. The legs are the sides containing the right angle. This is the right angle. This one is the right angle. This is the vertex containing the right angle. This is one leg. This is the other leg. Now, when you turn this right triangle about this leg, that means you keep this one fixed. You keep this as the axis. Either disturb panama, you're keeping this as the axis as if this is fixed. And you're turning the triangle. You turn the triangle. You turn the triangle, one full turn, and you come back to the starting point like this. The shape traced by this right triangle is a right circular cone. It's not magic that we turn the triangle and I can give you a cone. No, you don't get a cone. But when you turn the right triangle, this is the right angle to triangle. This is the right angle. This is one leg, this is the other leg. Okay. We are keeping the triangle fixed about one of its legs. So this one is fixed. And I'm turning the triangle. See, I'm turning the triangle. This is fixed. I turn the triangle. So below it is tracing a circle. Below it's tracing a circle. Because this is like the radius. This is the center. For the circle, this is the center. This is the radius. This is the radius. See, below, when I'm turning below, this one is, the tip is going to draw a circle. The tip here is going to draw a circle. So like this, see, the tip is, it's like using a compass and drawing a circle. And you come back. So when you turn a right triangle about one of its legs, the solid generated is a right circular cone. Meaning generated, meaning the solid traced is a right circular cone. It'll trace, you can just find it in the internet. You will find videos. Just search for that, you can see. And you should be able to visualize, but if you're not able to, you can also see the, just read out that to Google. Meaning just say that to Google and she'll show you the video. Is that fine? You can rotate, turn it up about this leg also. This leg also, when you turn it, you'll get a right circular cone. But if you turn it about the hypotenuse, it's a different thing. When you turn the right triangle about its hypotenuse like this, the solid generates a double cone, which you'll see next year. It's a double cone. You'll get a cone on this side, you'll get a cone on this side also. When you turn the right triangle about its hypotenuse, you fix the hypotenuse and you turn it like this. You turn it like this. The solid generated is a double cone. You'll get a cone will be traced on this side and another cone will be traced on this side. It will be like two cones stuck to each other. When a right triangle is turned about its hypotenuse, the solid generated is a double cone. This side will trace a cone on this side and this one will trace a cone on this side. So it will be like two cones stuck to each other. But when a right triangle is made to turn about one of its legs, this leg or this leg, when it's made to turn like this, the solid generated is a right circular cone. So this side will be the height of the cone. This one will be the radius of the cone. This will be the height of the cone. And this will be the radius of the cone. And this will be the slant height of the cone. The three sides of the right triangle will make the three values for the cone R, H, and L. For a cone, we have radius, height, and slant height, right? So whichever leg you're keeping it as fixed will become the height of the cone, H of the cone. The one which is turning, this is fixed. This one is tracing the circle, no? This is tracing the circle. So this side will become the radius. And this one is already slanting. This will become the slant height. Yeah. So now in this question, if the triangle ABC with sides 5, 12, 13 is revolved about the side 5 centimeters, that means 5 is kept fixed. 5 is kept fixed. It's revolved about that side 5 centimeters. That is 5 is fixed. If it's made to turn, the solid generated is a double cone. I'm sorry, the solid generated is a right circular cone. Then find the volume of the solid obtained. Find also the volume of the solid revolved about the side. Okay, I've made some mistake in typing there. You should also find the volume of the solid if it is rotated about the side 12 centimeters. And you should also find the ratio of the volumes of the two solids. Okay, let me explain the question. There is a right triangle. Children, there's a right triangle, children. Okay. 5, 12, 13, right triangle. Okay. In case 1, you're turning the triangle about the side 5 centimeters. So the height of the cone, the solid generated is a cone. And the height of the cone will be 12 centimeters. The radius will be no. Height will be, if it's turned about the side 5 centimeters, height will be 5 centimeter. The radius will be 12 centimeter and the slant height will be 13 centimeter. In case 2, the same triangle, but you're making this 12 centimeters stand like this. It's the same triangle. You're making it stand with 12 centimeters upright. And so 5 centimeters is here and 13 centimeters is here. You're turning, in the second case, you're turning the triangle about the side 12 centimeters. So what is the height? 12 centimeters. What is the radius? 5 centimeters. And what's the slant height? 13 centimeters. So can't we find the volume of the cone here? 1/3 pi r square h. But since you have two different cases here, you can call it H1, R1, L1, H2, R2, L2, because we have both the cases here. So here the volume will be 1 by 3 pi R1 square H1. Here it will be 1 by 3 pi R2 square H2. See, I'll write the whole thing again. Case 1, case 2. When you keep the right triangle like this with 5 centimeter upright, and this one 12 centimeters, and the hypotenuse is 13. You're keeping 5 centimeters as the axis and you're turning it about 5 centimeters. If you turn it about 5 centimeters, 5 centimeters will be the height of the cone formed, cone traced or generated. Radius will be 12 centimeters and the hypotenuse is always the slant height, 13. If you keep the triangle like this, 12 centimeters, 5 centimeters, 13 centimeters. If you keep the triangle like this and you turn it, that is, you're keeping 12 centimeters fixed and you're turning the triangle, correct? Then the height will be 12 centimeters, radius will be 5 centimeters, and the slant height will be 13 centimeters. So I should call it H1, R1, L1, H2, R2, L2. So how do you find the volume? In both the cases, you'll have to find the volume. How do you find the volume? 1 by 3 pi R1 square H1 and 1 by 3 pi R2 square H2 will give you the volumes. Correct? Then you have to find the ratio. To find the ratio, children, don't divide this answer by this answer. Don't do that. That will take some time to find. Don't do that. Whenever you have to find the ratio directly. Required ratio is equal to 1 by 3 pi R1 square H1 by 1 by 3 pi R2 square H2. Don't use these answers. 1 by 3 pi gets cancelled. What is R1 square? 12 into 12 into 5 divided by R2, 5 into 5 into 12. So see, 12 and 12 gets cancelled, 5 and 5 gets cancelled. So 12 by 5 is a required ratio. 12 by 5 is a required ratio. Whenever you have to find a ratio, use the formula directly there. If you use these answers, if you use the answer here and answer here, supposing this answer is a decimal and this answer is a decimal, you will not get a good ratio like this. This is a perfect ratio. You will not get this. You will not get this answer. You will get something close. It will not be incorrect, but you will not be able to get this exactly 12 by 5. So whenever you have to find a ratio, use it like this. Use the formula. Don't use, see, you have to find the ratio of this volume to this volume. Don't use this answer divided by this answer. Use the formula. Required ratios, volume of the first cone by the volume of the second cone. 1 by 3 pi R1 square H1, 1 by 3 pi R2 square H2. Now when you substitute the values, you will get the perfect ratio. Which one? What did we discuss in the last class actually? Louder, louder. One of you louder. Louder. What did I send on WhatsApp? One second. I'll help. Yeah, which two answers? 11 and 12. No, come here and show me. I have my WhatsApp open. Show me which one. These are this. Pink color background. This one. Oh, yeah. Thank you. Thank you. Thank you. Thank you so much. 11 and 12. Which one is this? Any date I mentioned that day? Well, luckily, I found it. I think it's this one only. This one, right? So thank you, Abhishek. You always, help me with this. Thank you so much. All right. So Abhishek just reminded me that in the last session, I said I had promised that I'll explain two sums in the next class. So it's about 11 and 12. These images were shared with you on WhatsApp in the last class. So you have the answers with you, but 11 and 12, I did not explain. Till 10, okay. See this question now, after having understood so much, this is not a difficult question for you. The inner diameter of a cylindrical wooden pipe is 32 centimeters and outside diameter, inside diameter, outside diameter. So you can find the inside radius and outside radius, small r, capital R. Length of the pipe is given. That means the height of the cylinder. So the cylinder is like that sellotape thing. Whenever there is two radius, the cylinder is like that sellotape example. It's a hollow cylinder, cylindrical shell. The length is 56 centimeters. Find the mass of the pipe if 1 centimeter cube of wood has a mass of 1.5 grams. 1 centimeter cubed, 1.5 grams. So we should find how much centimeter cube is there in this cylindrical wooden pipe. What is the solid in the question? It's a pipe. What material is this pipe made of? Wood. The pipe is made of wood. And what is the shape? It's a cylindrical pipe. The wall is thick. That's why two radius we can see. The wall is thick. That's why two radius. So imagine that sellotape. Sellotape is that's how it looks. That's the kind of object you have to imagine for a pipe. So inside radius, outside radius, and height, which is the length of the pipe, 56 centimeters. It's clearly given that 1 centimeter cube of wood has a mass of 1.5 grams. So you should find how many centimeter cube is there in that wooden pipe. So how do you find how many centimeter cube? Volume. Sana, is that part? Sana. Oh, you're looking too tired and I'm saying 1 centimeter cube has a mass of 1.5 grams. Even you, Mritsa. Volume kandupidikanum sollane. Is it fine or no? You're not getting that. Yes or no? Yeah, Bhavishya. No, what I'm saying is, no, see here. What is given? 1 centimeter cube. Na, centimeter cube is a unit for what? Volume, right? Mritsa and Sana like invigilators for me, no? They'll not acknowledge immediately. No, darling, what I'm saying is 1 centimeter cube. Centimeter cube in the unit எப்ப use பண்ணுவோன்னு கேக்குறேன். Volume ka area ka. அதுதான் 1 centimeter cube na அது ஒரு volume தானே சொல்லுதாங்க. 1 centimeter cube represents volume or surface area. 1 centimeter square represents area. But 1 centimeter cube represents volume. Why volume? Because centimeter cube. So it's volume only. So what is given in the question is this volume, 1 centimeter cube, has a mass of 1.5 grams. If this volume has this mass, should find the volume actually in the pipe. That volume will have how much mass? So it's easy to understand that we have to find the volume because they have given you that this volume of wood, 1 centimeter cube of wood has a mass of 1.5 grams. So you should find how much centimeter cube is there in this wooden pipe. That means volume we have to find. So this is the formula. You can write this straight away. Pi h capital R square minus R small r square. Directly you can write this. You don't have to write. You can write this straight away. This is the formula. Pi h capital R square minus small r square. So substitute. Values of their height is this one, 56. Then the radius and all that is given to you. Work, you get this one. 1 centimeter cube, 1.5 grams. So many centimeter cube, how many grams? So you'll have to multiply. It's like saying 1 kg is 10 rupees. So 15 kgs will be 15 into 10, 150 rupees. In the same way, 1 centimeter cube is 1.5 grams. 11968 centimeter cube will be 11968 into 1.5 grams. The question always is if we have to find volume or area, it depends on what is given. It's very clearly given 1 centimeter cube, which represents volume because this unit is about volume. So if 1 centimeter cube has a mass of, like saying 1 kg is 15 rupees. Like that, 1 centimeter cube is 1.5 grams. So you must find how much centimeter cube is there in this wooden pipe by using this formula pi h capital R square minus small r square. So many, this is the volume. This is the volume of this pipe. So 1 centimeter cubed, 1.5 grams. So much centimeter cubed will be, you should multiply this one into 1.5. So you get 17,952 grams. To convert that to kilograms, divide by 1000. To convert it to kilograms, divide by 1000. So 17.952 kilograms. This will be 4 marks. Abhishek got 4 marks now itself. Yeah. I'll just finish this one and wind up the session for today. The diameter of a spherical solid. No, see, you have to ask me if you don't understand, children. Now, I don't know how to be more good. I think I'm good. But if you feel I have to be more friendly, please ask me. If you ask, I can. If you ask a doubt, I can explain better because I'll understand what your confusion is. Sahana will not talk whatever happens. These three of you, Aragama is spreading her, her vibes to both of you, the left and right. You must make her talk. Instead, both of you becoming more and more quiet like her. See, I'm sure from the girls, only Blessy conveys that she has understood. Only Blessy. Bhavishya, sometimes she'll say, okay, with her eyes. Sometimes I understand. Only Blessy acknowledges. She doesn't say anything special to me, but the way she looks and the way she expresses her facial expression, I'm 100% sure she understands. She doesn't have a doubt from the way she looks. You don't show any expression at all. So I don't know. When I see your face, I get scared. I start questioning myself as a teacher. Am I doing a good job or am I wasting my children's time? You also, Mitsa, you are also a terror for me. No, I don't know because you're like that only. Boys, Krishna Priyan always understands. Always understands. He is very focused. Krishna Priyan is highly focused. He understands, but he's very naughty. He's equally naughty. But he is focused. He does understand. Abhishek also understands. Hariharan and I think yes, Mohit is also now trying to. You're looking better. Yes. The problem is we don't know the formula, so we are like, okay. I'm not saying the others are not following. I don't know is what I'm trying to say. Online students, I can't say. Only if you ask me or you acknowledge, I can make out. So from the students here in the class, you're not giving me any signal, is what I'm trying to say. I'm not saying that you're not following anything. I'm only trying to say that I don't understand anything from your face. See that again. Please ask me questions if you don't understand. Please ask me. When you ask me a question, you help me to explain better. From the question, I can understand the type of doubt you have in your mind. You have to express. The diameter of a spherical solid is approximately 2/3 of the diameter of another spherical solid. What fraction of the volume of the second is the volume of the first? So similar to that we saw today, exercise 13.8. We saw something like this, no? We had to find what fractions of the volume of the earth is, what fraction of the volume of the earth is the volume of the moon, correct? Yeah, similar question. Similar question. So write it in words. The diameter of a spherical solid. Diameter of a spherical solid. So we'll just say D1, okay? Diameter of a spherical solid. Or you can use small d and okay, D1. The diameter of a spherical solid is approximately 2/3 the diameter of another spherical solid. See, I might have worked it in a different way here. So I've given smaller. Anyways, you can do it. I'm calling it D1 and D2 here. D1 is the diameter of that first, spherical solid. D2 is the diameter of the second one. So the diameter of a spherical solid is approximately. Diameter of one spherical solid is approximately 2/3 of the diameter of another spherical solid. See, whatever is in English, we are converting that to an equation. See, diameter of a spherical solid, D1, means equal to 2/3. So 2/3 of means into diameter of another solid, D2. So what is D1? What is diameter? Twice radius. So twice radius. This is also twice radius. But how will you differentiate? So R1, R2. I have in my working, I have used small d and small r, capital D and capital R, whatever you want. You can also do it like this. Is equal to 2 by 3 into. Now what happens? 2 and 2 on either side gets cancelled. So you will get R1 is equal to 2 by 3, 2R2 by 3. R1 is equal to 2R2 by 3. Correct? 2 and 2 on either side gets cancelled. So R1 is equal to twice R2 by 3. This is the relation. Now the question is, what fraction of the volume of the second is the volume of the first? So which one will you write first? Will you write volume of the second one by the first one or first one by the second one? It's time auto vandirukkom. Okay, it's time, children. So because some of you, your automaton would have come, right? Yeah, so I'll not take more time. It's just understood. The first part I've explained. The rest you can see the working. That's what you have to do. Then you get a relationship between R1 and R2 or small r and capital R. Then you should find the fraction. So you can see here. I've used for the first spherical solid, I've used these letters. For the second spherical solid, I've used these letters. All right, I've used these letters. Then the diameter of the first one. The diameter of the first one is 2/3 the diameter of the second one. 2 by 3 the diameter of the second one. Correct? So every time I work, I do it differently. So I've written d by d is equal to 2 by 3. D means 2r. This d means 2r. So 2 and 2 will get cancelled. So r by r is 2 by 3. Now we have to find the volume of the first sphere by the volume of the second sphere. Volume of the first sphere by the volume of the second sphere will be, volume is 4 by 3 pi r cube. 4 by 3 pi r cube. 4 by 3 pi gets cancelled. R cube by r cube, r by r the whole cube. Substitute. R by r is 2 by 3. R by r is 2 by 3. So 8 by 27. All right. These images you already have. So tomorrow I have to send exercise 13.7 and 13.8. So we have covered a major part of this chapter, almost 95%. I'll have to check if any more important questions are being not handled. So Tuesday, please come prepared with the formulae. Go through the chapter. You have holidays now. So go through the entire chapter, come prepared. We'll take a revision on Tuesday. All right. All right, children, online students. So that's it for today's session. Thank you so much. You may leave the call. Thank you, children. Good night.
Thank you, Miss.
Thank you.
Ma'am.
Thank you, ma'am. Thank you. Good night.